Hello guys, welcome back. We're looking at activity 12 today. We're talking about the idea of flowchart proofs. Hello, I am Mr. Williams. And so today we're going to be talking about flowchart proofs. Flowchart proofs are one style of proofs. You've already seen several. The most common, honestly, or kind of what we start with is really the paragraph. I think the one that makes the most sense probably is the two column because you're listing a reason on the right side and then on the left side you're putting what's happening. Flowchart proofs are pretty much the exact same thing as the two-column proof. You're just showing causality. You're showing kind of that's why they call it a flowchart. You're showing what would happen, okay? So what I'm going to do, we're going to be on page 167 or activity 12.1 in the book. I'm going to walk you through the first example and the try me section and kind of make sure that makes sense for you, and then I'm going to let you practice on your own. I really like this section, but I'll warn you the whole section as far as the main part of the bookwork actually boils down to a single proof. So it feels like you're doing a lot, but it really is just one proof. It's just a step-by-step idea. Before we do that, we really need to kind of remember some stuff and remember some vocabulary and remember kind of what we've done. So one of the big things that shows up in this section, and really whenever we're doing proofs, is triangle congruence, okay? Now, you should have already learned your shortcuts. You should have already learned side, 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 angle, side. What are the other ones? Angle, side, angle, 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 side, and that's 4. What's the other one? Hypotenuse, leg, okay? So you have 2 when it comes to sides, and you have 2 when it comes to angles. So basically what happens is you have to know all the sides, or you have to know 2 sides and the included angle, so the angle of those 2 sides make, or you have to know 2 of the angles and 1 of the sides, and those have to be the same kind of relationship. And the reason that matters is because a lot of these proofs, almost all the proofs in this section, deal with basically proving that 2 triangles are congruent. And in order to prove they're congruent, we use the shortcuts. We use showing those 3 things. And if you can show those 3 things, then the triangles match, okay? And then some of these proofs actually go an extra step further, and we use what we call CP-CTC. Corresponding parts of congruent triangles are congruent. Or in some textbooks, it'll say corresponding parts of congruent figures are congruent. Basically meaning, hey, if 2 shapes are exactly the same, then their shortest sides are the same length. Or their biggest angle is the same length, that kind of thing. And we kind of studied that when you looked at congruence, when you looked at congruence figures. One congruent figure is congruent to another congruent figure only if everything about it matches, all the sides and all the angles, okay? It just so happened that we found some shortcuts, and that's where the side, 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 angle, side, angle, side, angle, and angle, angle, side come in, okay? Those are shortcuts for us. So what we're going to do again is we're looking at page 167 is kind of where this starts, and I'm going to kind of walk you through the example that's on that page. That's actually this drawing up here, and of course my drawing is not as good as the one in the book, so you're welcome to look in the book. But it gives us a drawing like this. We've got D over here, and then we've got ABC down the middle, and they tell us 2 things. They tell us, hey, the DB bisects AC, meaning that this line right here bisects this line. How do we know that it bisects it? Because they told us, okay? And how can I mark that? Do y'all remember how we can mark congruence? Well, what I'm going to do is I'm going to go ahead and mark it on the picture. I'm not doing the proof yet, but I found that if I draw the picture, if I draw what they're talking about, and I mark the picture with my congruence and with the things that match it, a lot of times it makes it a lot easier for me to recognize what my reasonings are going to be. And in this case, what we're shopping for, what we're looking for, is that shortcut. We're looking for all the sides match, or side angle side, or side, something like that, angle angle side. So we have DB bisects AC. In and of itself doesn't matter. So we have to ask ourselves, what does it mean to bisect? It means it cuts something in half. It means that it makes this section congruent to this section, okay? So what you always want to do is look at your given statement and ask yourself, why do I care, right? Why do I care that it bisects it? Well, if you look at what they're trying to prove, the proof statement here is triangle congruent to triangle, okay? And you've got it there in your book as far as the letters and everything, but in essence what they're trying to prove is triangle equals triangle. And the way we prove triangle equals triangle, so we're looking kind of at these red boxes, this is the first example. The way you prove triangle equals triangle is one of the shortcuts, okay? So what that lets me know, just so you understand kind of the way this is laid out, this is going to be one of the shortcuts. This is either going to be a side, an angle, a side, a side, a side, a side, an angle, a side, or an angle, a side, an angle, okay? That's what these 3 boxes are giving me, are the shortcut, and whatever that shortcut happens to be, that's going to be my reason that goes here, okay? So if you've ever done a maze or something like that, maybe comes on, one of the kids menus where you kind of get the maze. Sometimes if you go backwards, it's easier, and that's true for proofs as well. So if you realize, hey, I need to prove triangles match, oh, I need one of my shortcuts, okay, I only have a few options for my shortcuts, and I have 3 things there, so okay, I need to figure out what those are. Then we go back and we say, okay, wait, DB bisects AC. Well, that in and of itself doesn't matter. Again, we care that it's congruent, but that's our given. So your first box is always going to be your given. And then we simply write whatever they said. DB bisects AC. Okay? And again, why do we care that it bisects? Because it's bisected, it tells me that the parts are congruent. So A, B is congruent to B, C. All right? Now, keep in mind, AB is the same as BA. Like, if we're talking a segment, the order doesn't matter. The reason I mention that is I'm not copying this from the book. So if the book has the order switch, that doesn't actually change anything. So just FYI, all right? What's my reasoning? Why is that true? Well, what was this word, bisect? This is definition of bisect. Okay, because that's what it means to bisect something, is it cuts it in half. It makes 2 congruent parts, okay? And that's why we care. All right, now let's talk about these next 2. Notice we only have one more given statement, so one of them is going to be a given statement. I'll go ahead and put that here. That gives me DA is congruent to DC, and we're going to say given for that one. And I'm going to go ahead and mark that on my drawing. So DA matches DC. That means this length matches this length, okay? What else do I have? Do I know any of them? I need what? I need either an angle that would be between those. So I either need to know that this angle matches this angle, which I don't have anything that tells me that, or I need the third side. What's the third side of both triangles? What's the third side of both triangles? Notice they share that middle line. What's the letters for that middle line? D, B, for both triangles, right? So I can say DB is congruent to DB. That's like saying A equals A or 12 equals 12, okay? You're not actually saying something, but you are saying something. It gives you a step in your proof. Now, what is our reason for that? It's not a definition. This is called reflexive property. Reflex. Prop. It's on page 26 in the book, has a list of some properties that are useful in the proofs, okay? So reflexive property, that lets us know that, hey, we can say 5 equals 5 all day long. I don't know how long BD is in the top triangle, but I know it's the same thing in the bottom triangle, all right? And that's the idea. Now what happens? When I do that, now I can mark this. Now all of a sudden I have side, side, side. I have side, side, side. So my triangles match because of side, side, side. And there's your first example, okay? We're gonna go ahead and do the second example. Pretty much same idea, all right? Same basic idea. We're gonna start with what they've given us. Here's our drawing for the second one. We're moving on to the next page now, so I think we're on page 168, yeah. We're looking at try these A. They give us this drawing and tell us, hey, by the way, the opposite sides are parallel to each other. Remember, that's what that symbol means when they're straight up and down, it means parallel. Why do we care? Well, think about what we did. And this is the problem with this class and why you really need to pay attention. They're gonna call on the information from yesterday or the information from last week. In this case, they're calling on the idea of parallel lines cut by a transversal. They want you to notice that, hey, PQ versus SR. So this top line is parallel to the bottom line. Why do we care? That tells us that the alternate interior angles, right here and right here, are equal to each other, okay? What else do we have? Well, we're given that QR equals PS. So same idea, this side is parallel to this side, and we kind of draw the matching arrows. Why do we care about that? That tells us that these alternate interior angles are equal. Notice I'm not dealing with the outside, right? Because these would be same side interior, and they would be supplementary, and that wouldn't be useful. We need congruence here. So I get these 2 angles match. All right? What have I not done? I haven't even started writing my proof. I'm just kind of working with my drawing, seeing what I can notice. What else can I notice in this drawing? Well, think about the first example. What did they do? They had BD was in both triangles, right? What's in both of these triangles? Do you see it? Top triangle, bottom triangle, what do they share? They share this side, okay? They share that side. So let's kind of walk through what we have. We have our given statements. So PQ parallel to SR, that's given. we have QR is parallel to PS. That's given. Why do we care? It gives us angles. It gives us, let's see, we've got QPR is congruent to angle, so QPR, that's this top one here with a single mark, be congruent to this bottom, so SRP. So SRP. Okay? Now we look at QR versus PS, so this up and down. That gives us this angle and this angle. Remember the middle letter, there's going to be 3 letters, SPR. The middle letter is the vertex, so SPR is congruent to angle, so the SPR. Now we're going to do this one, so QRP. QRP. All right, and these were both definition. No, sorry, bad teacher, not definition. This is alternate interior angles theorem. Remember it says that if 2 lines are parallel, then the alternate interior angles must be congruent. Okay, so you can write AIA, you can put alternate interior angles theorem. Last thing we had is kind of what we noticed in the picture, right? This is not one of the given, but it's in the picture, and that is the same property we used last time, that PR equals PR, or is congruent to PR, and that is the same reflexive property. Okay? Now what do we have here? We have an angle, and a side, but be careful. Notice that the side is between the angles. If I were to highlight just this triangle on the bottom, if I'm looking just at the bottom triangle, here's the angle that I'm talking about, here's an angle that I'm talking about, and here's the side. So I have angle, side, angle. So my reasoning here, and I bring this up because you'll miss a question on the test if you're not careful with this. I have triangle equals triangle, which is what I want, but my reasoning is going to be angle, side, angle. Not angle, angle, side. It doesn't matter how it's listed in the proof, it's how it is in the drawing. Okay? So please, please, please be careful with that kind of stuff. Alright? Hopefully that makes sense. Now what I'm going to do is I'm going to give you some time. This is a sketch of the proof. It is a little bit longer proof. It's not any harder than these, it's just a little bit longer. And what the book's going to have you do is it's going to have you go step by step. Alright? So starting on page 168 actually is where they give you the problem. Then question number 2 on page 169 is going to ask you to write a paragraph proof. So I want you to kind of sketch out the idea. How do I prove, and what you're trying to prove, is that the lines are parallel to each other. How do I prove that? Okay? And so I'm going to let you struggle with that a little bit. And I say that very lovingly, and I mean it. I'm going to let you struggle with it a little bit because I believe you're going to struggle with this proof a little bit unless it just really makes sense to you. But what you're going to do is I'm going to give you about 15 minutes. I want you to go do numbers 2 through 12. Starting on page 168, you're going to do numbers 2 through 12. All right? I'll see you in a few minutes, guys.